All right, we move into the packet and we look at 9.46. Power companies trim trees growing near their lines to avoid power failures due to falling limbs in storms. Applying a chemical to slow the growth of the trees is cheaper than trimming, but the chemical kills some of these trees. Suppose that one such chemical kills 20% of the sycamore trees. The power company tests this chemical on 250 sycamores. Consider this an SRS from the population of all sycamore trees. A, what is the mean and the standard deviation of the number of trees in the sample that are killed? So what we have to do with this one is, decide whether it's a sample mean or sample proportion. And right now, the thing we're looking for is if we're given a standard deviation. And since we're not given a standard deviation at all in the problem, we're going to treat this question as a sample proportion. To answer part A, we have, conditions that need to be met. So let's go ahead and meet those conditions or satisfy those conditions. Well, condition number one is that it's an SRS, and this is true because it was stated in the question, stated in problem. Talks about it right here. Next, number two is that the population is 10 times the sample or larger. And we're talking about our sample N being 250, which means our population of all sycamore trees would have to be more than 10 times that, or 2,500, and that's a safe assumption to say. And then number three, we need N times P, N times P greater than 10, and then N times 1 minus P, also greater than 10. Our N is going to be 250. Our P, according to our problem, is 0.2, and that needs to be greater than 10. 250 times 0.8 needs to be greater than 10. And when we look at 250 times 0.2, we're going to get 50, and 50 is greater than 10. And 250 times 0.8, and that's 200, and that's greater than 10. So we're good in both cases. Now remember, this is telling me we can assume the distribution is normal here, and this is telling me I can use the standard deviation formula, P times 1 minus P over N. All right, so now let's get to part A in terms of answering. It says, what is the mean and standard deviation? Well, the mean is going to be, it's going to take on the same value as the mean in the population because we're dealing with an SRS. So the mean is going to be 0.20, and if the question wanted to know exactly how many trees, well, if you're taking 250 and you're multiplying it by 0.2, we have that calculation down here. We're talking about the mean of 0.20, which is talking about 50 trees. And the standard deviation, well, the standard deviation is going to be that formula now we're allowed to use because this was satisfied. Our P is 0.2. We're going to multiply that by 0.8, and we're going to divide that by 250. So the standard deviation for the problem will be 0.2 times 0.8. And we're going to divide that by 250. And we're going to take the square root of that number. And we're going to get 0.0253. All right, so there we go. So now we're going to be asked a question in B, and B is going to be, what is the probability that at least 60 trees, or 24% of the samples are killed, or 24% of the samples are killed. So what we're going to do is we can start by saying conditions satisfied in part A, and we know that the distribution we're going to be using for this problem is going to be normal with a 0.2 as a mean and a standard deviation of 0.0253. That's the information we can pull from A and use in this problem. So now let's restate what the question is trying to ask us. It says, what is the probability that at least 60? So probability that our p hat is going to be greater than or equal to 60. We need to rephrase that. At least turns into a 1 minus. Probability that p hat is going to be less than or equal to 60, or just less than 60. So now what we have to do to be able to answer this question is we have to come up with a z-score for 60. So the z-score for 60 is going to be, and again, I probably shouldn't have used the 60 piece. I should have used the 0.24, so that's what I'm going to go back and change, because we're keeping this as a sample proportion. We don't want to mix those numbers up. So now it's going to be the z-score for 0.24. So 0.24 minus 0.2 divided by 0.0253. This is going to equal, again, on the calculator, I'm going to have 0.24 minus 0.2. That gives me my 0.04. I'm going to divide that by 0.0253. And we're going to get 1.58 as a z-score. So now to finish this, it's going to be 1 minus the probability that that z is going to equal 1.58, right, or less than 1.58, but when we use this, it's fine to do that. And that's going to equal 1 minus, and then we're going to look it up, 1.58, going through our tables. Okay, so here's our table. We're looking for 1.5. So 1.5 is here, going across to 8. There's 6, 7, 8, 9, 4, 2, 9. 9, 4, 2, 9. So coming back, 0.9429, do that subtraction, 1 minus 0.9429, and we're going to get a probability of 0.0571. Okay, that means that if we pull any sample of 60 trees, or not 60 trees, any sample of 250 sycamore trees, that we get 60 or more of those trees that are going to be killed by this chemical, the probability of finding that is going to be 0.0571.